So today's topic is solution of a differential equation using power series method. Under this topic, we'll able to learn how to solve a differential equation using power series method. For that, let us consider an ordinary differential equation of nth degree as dny dxn plus p1x dn minus y dxn minus 1 plus p2x dn minus 2y dxn minus 2, continuing in this way, pn minus 1x dy dx plus pnx equal to rnx, where each of p1x p2x dot dot pnx are either functions of x or constant. Now in our case, we will consider a second order differential equation of the same form as mentioned above. dny dxn plus p0x dn, suppose it is, since we are considering second order, it will be d2y dx2 plus p0x dy dx plus p1x y equal to rx. Now there may be some problem where there are some coefficients within this part, so we can make it this coefficient 1 by dividing each by the same coefficient. My point is, not always this coefficient of d2y dx2 will be 1. So if something is with d2y dx2, you divide both sides of the equation by that coefficient so as to make this coefficient as 1. যদি তোমরা দেখো যে এখানে কোফিশিয়েন্টটা 1 হচ্ছে না, যদি অন্য কোনো কোফিশিয়েন্ট থাকে তাহলে সেটা দিয়ে পুরো ইকুয়েশনটাকে ডিভাইড করে এটাকে 1 বানাতে হবে। ডিভাইড করার পর যেটা পাবে সেটা হবে p0x and p1x even rx. After dividing, what you will get, that will be p0x, p1x and rx. Clear? Now mark this equation as 1. A point x equal to x0 is called an ordinary point if both p0x and p1x are defined at x equal to x0. A point x equal to x0 is called an ordinary point of 1 if both p0x and p1x are defined at x equal to x0. They must be defined at that point. Otherwise x equal to x0 is called a singular point. X equal to x0 is called a singular point. So if both p0x and p1x are defined at the point x equal to x0, then x equal to x0 is called an ordinary point. Otherwise, they are called a singular point. The point is called a singular point. Now, singular point can be classified into two parts. Number one, regular singular point. Number two, irregular singular point. তার মানে এখানে দেখো, যদি একটা পয়েন্টে p0x and p1x দুজনে ডিফাইন না হয়, যদি কোনো একটা আনডিফাইন্ড হয়, তাহলে সেই পয়েন্টটাকে বলা হবে সিঙ্গুলার পয়েন্ট। এবার এই সিঙ্গুলার পয়েন্টের ইনসাইডে এর দুটা ক্লাসিফিকেশন আছে, একটা হচ্ছে রেগুলার সিঙ্গুলার পয়েন্ট আর একটা হচ্ছে ইরেগুলার সিঙ্গুলার পয়েন্ট। সো এগেন আই এম রিপিটিং, সাপোজ if one of p0x or p1x fail to be defined at x equal to x0, then x equal to x0 is called a singular point. Now singular point can be classified into two parts. One is called regular singular point, another one is called irregular singular point. Preciously, or more accurately, you can call it as RSP, regular singular point, and this as IRSP, irregular singular point. Now again I am going back to the heading of this part. The heading is solution of a differential equation using power series method. Now there is a valid question why we are discussing these few different kind of points. So the answer is, we can find power series solution of a differential equation only when the point is ordinary point as well as regular singular point. There is no power series solution for irregular singular point. কোশ্চেনটা হচ্ছে শুধুমাত্র অর্ডিনারি পয়েন্ট এবং রেগুলার সিঙ্গুলার পয়েন্টের জন্যই পাওয়ার সিরিজ সলিউশন থাকবে, বাকি ইরেগুলার সিঙ্গুলার পয়েন্টের জন্য দেয়ার উইল বি নো সাচ পাওয়ার সিরিজ সলিউশন। So first we will learn how to find power series solution for an ordinary point in this lecture. In my next lecture I will teach you how to find power series solution for regular singular point. Okay, now come to the solution part. Suppose you have this differential equation d2i dx2, for example d2i dx2 x square plus x cube dy dx plus 2x4 equal to 0. Let's say you have this differential equation. Now as I told you, if some coefficient is with d2i dx2, you have to divide that coefficient by the both side. যদি d2i dx2 এর সঙ্গে কোনো কোএফিসিয়েন্ট থাকে, তাহলে তোমাকে বোথ সাইড সেটাকে ডিভাইড করে নিয়ে এই কোএফিসিয়েন্টটাকে 1 বানাতে হবে। You have to make it 1. For that, let us divide d2i dx2 plus x dy dx plus 2x square equal to 0. Number 2. Now we get the point that the coefficient of d2i dx2 is 1. আমরা পেয়ে গেছি d2i dx2 coefficient 1. So what we got over here as the coefficient of dy dx, and here at the free term will be treated as our p0x and p1x. So p0x will be x, p1x will be 2x square. Now suppose if we focus suppose if we focus on the point x equal to 0, then both p0x and p1x are defined at x equal to 0. এখানে দেখো p0x মানে x আর p1x মানে 2x square দুজনেই 0 পয়েন্টে defined because their value is 0, so it is a defined value. So my point is both the functions x and 2x square are defined at the point x equal to 0. So therefore my conclusion is x equal to 0 is an ordinary point, isn't it? X equal to 0 is an ordinary point. Now the target is how to solve it. The first target is to check whether a point is ordinary or not, because as I told you earlier also, we have power series solution only for ordinary point and for regular singular point. So since we got here it is an ordinary point, so it has a different type of power series solution method, and for regular singular point we have different type of power series solution method. So let us get back to the power series solution method for an ordinary point. For that, let y equal to summation n equal to 0 to infinity an x to the power n be a solution of 2, a solution of 1. Now we can assume, consider the main differential equation. যখন তোমরা সলিউশন বের করছো তখন তোমরা মেইন ডিফারেনশিয়াল ইকুয়েশনটাই নিবে যেটা তোমার দেওয়া আছে। খালি p0x and p1x বের করার সময় when you want to find p0x and p1x, you have to divide this coefficient by the term of coefficient of d2 dx2. Now this is a solution of 1. Look, here I consider x to the power n. Actually the point is, since the ordinary point here 0, that's why I consider x minus 0 to the power n, that is x to the power n. If instead of 0, if something else is an ordinary point, we can consider that point x minus that point to the power n over here. For example, suppose x equal to 1 is an ordinary point, then you have to consider x minus 1 whole to the power n. যেরকম অর্ডিনারি পয়েন্ট হবে তোমরা সেরকমই এখানে a কে কনসিডার করবে। সিন্স হেয়ার x is 0, you consider x to the power n. যদি অন্য কোনো পয়েন্ট হতো তোমরা নিতে x minus a whole to the power n. Now y equal to this be a solution of 1. Now what will be the dy dx? Tell me. Dy dx will be summation n equal to 0 to infinity an n x to the power n minus 1. N equal to 0 to infinity an n x to the power n minus 1. If you put the lower limit n equal to 0, the value will be 0. So instead of starting from n equal to 0, we can start this series from n equal to 1. দেখো এখানে যদি তোমরা n equal to 0 বসাও তাহলে এই টার্মটা ভ্যানিশ হয়ে যাচ্ছে, তাই সিরিজটা 0 থেকে স্টার্ট না করে আমরা 1 এর থেকে স্টার্ট করতে পারি। Instead of starting the series from 0, we can start it from 1. Okay. Now d2i dx2, because we need till second order derivative. d2i dx2 will be summation n equal to 1 to infinity an n minus 1 x to the power, oh there will be one more n over here. It will be summation n equal to 1 to infinity an n minus 1 x to the power n minus 2. Now if you put n equal to 1, this term again vanish. এবার দেখো তোমরা যদি 1 বসাও তাহলে এই টার্মটা ভ্যানিশ হয়ে যাবে, তাই 1 না বসিয়ে তোমরা এই জায়গাটায় 2, you can start this series from n equal to 2. So this is d2i dx2. Now we got y, we have y, we know dy dx, we know d2i dx2. You just substitute all this value in equation 1. Name them. The first one is 3, then this one is 4, this one is 5. So substituting 3, 4 and 5 in equation 1, we get, just put x square d2i dx will be summation n equal to 2 to infinity an n into n minus 1 x to the power n minus 2 plus x cube. First of all, I have to say that this is just an arbitrary problem. আমি কিন্তু এটা জাস্ট একটা কোশ্চেন নিয়েছি, সো এখানে অ্যান্সার যে ঠিকঠাক পাওয়া যায় তার কোনো মানে নেই, কিন্তু ইউ ক্যান হ্যাভ আ ওভারভিউ হাউ টু প্রসিড. x cube dy dx summation n equal to 1 to infinity an n x to the power n minus 1 plus summation 2x to the power 4 n equal to 0 to infinity an x to the power n equal to 0. Ebar, now we can take this x square inside. 2 and n minus 2 will become n. N minus 1 and 3 become n plus 2.